Hello, this is Dr. Mears. Today we are going to be doing some application examples with quadratic models. So let's go. So here are some notes that we'll definitely need, and you might even want to go back to or even just take a picture so that you have them in your back pocket. Of course, maximum, minimum, x and y intercepts, according to the problem, you really have to understand them in context. But here are some notes that are going to help. First, when the problem asks for maximum or minimum, you want to find the vertex and then find which variable they want the answer for. Number two, about x-intercepts in distance, we could have how far an object traveled or the length an object measured. The problem could also say, something about time, and the x-intercepts could represent how long an object was traveling. Remember, there may be two intercepts, so you'll have to look at the graph to get the context of the question. 3, the y-intercept always refers to some type of start point. And again, you have to look in context of the question. And then 4, we need to be careful about how the equation is written. We're not going to be doing any solving mathematically. We're going to be using Desmos with these. But if you did have to solve it by hand, you may need to rearrange the equation so it's in that proper standard form that we're used to. So just something to be careful of. All right, example 1 is our suspension bridge, and what I did is I tried to include a picture of everything so that we can use our imagination, because when we actually put this on the graph, we're going to be putting this on a graph, I want you to understand what part of the bridge we're looking for. So we are looking at the side view of a suspension bridge, and it can be modeled by the equation f of x equals 0.00097722 x squared minus 1.167x. where x is the horizontal distance in meters and f of x is the depth in meters. What we're going to be doing is first plotting it on Desmos, as we're going to be doing with all of them, finding the coordinates of the points where the graph crosses the x-axis, seeing what they represent, finding the vertex, and what we think each number of the vertex represents. So let's go. So remember, here is the bridge. So in graphing it on Desmos, you can just go to Desmos and you can put in exactly what the equation is. It's going to give you this. Now what I have done is I have labeled each part, and on each one of my Desmos pages I have done that because it's so important to know what x and y represent. So let's just quickly go back here. So what I did is I kept this out and I said, okay, x is the horizontal distance in meters. So everywhere that I had an x value, x, I put horizontal distance. X, horizontal distance. X, horizontal distance. And everywhere that I put a y, I went back, or f of x, which it could be y, is the depth. That's how far down our bridge goes. And so everywhere that I had a y, I wrote depth in meters, depth in meters, depth in meters. So now that I have everything labeled, it's going to be really easy to go back and find out what each of these numbers represent. So let's just look at the bridge right here, and let's just go back to this picture, because what part of the bridge that they are looking at is this part right here. So here's from one x-intercept to the other, and here is that vertex. So that's the part of the bridge that we just graphed using this equation. That's this. So if we go here, this is how to think about it. So here is the graph, here is the bridge, and these are all the little suspension. That's why it's called suspension, right here. So that's the part of the bridge. You don't have to worry about that. So it's just from one of the tall pillars all the way down to ground level, all the way back up. So how the depth of it, actually bridge level I should say, we're traveling probably over something, so there's no ground. Okay, so the first question, it said, part B actually, find the coordinates of the point where the graph crosses the x-axis. So here's the first one, and we see that it's at 0, 0, and here's the second one, and it's at 1200.37, comma 0. So this is that first number, this is a comma, and that is that second number. And we have to see what they represent. So if I ask you this question, then simply write down the points. Here are my x x-intercepts. Now here's the thing, horizontal distance in meters. That means from 0, from that first high start point, all the way to this one. This is how long the bridge is going to be, that section of the bridge, should I say. So that section of the bridge. So the x-intercepts, I'm actually going to add a word in here. The x-intercepts tells us about the distance of the bridge, specific section. I'm going to write that in. We can subtract the 1200 minus 0, and this is going to come in handy, so I'm just subtracting this number from this number to get the total distance of that section. So the bridge is 1,200.37 meters long for that section. So what I'm talking about is if we go back here, from this all the way over to here, it's 1200.37 meters long. And that's why you have to use your imagination, because you have to really picture how long that section, this section of the bridge is. Okay, next, find the vertex. What do you think each number represents? So the vertex is this minimum point right here. So remember, this is the horizontal distance. From this point to this point, it's the horizontal distance, and from this point to that point, which makes sense because if you split 1200 in half, you get 600, so it's like halfway. So if we walked halfway, we would be at the vertex. And this is how far down, that's the depth. So let's just write that out in a complete sentence. And again, if I was giving this to you, you would first write the point down, and then you would say from one end of the bridge to another is, from one end of the bridge to the middle, from one end of the bridge to the middle is 600.185 meters long. The depth of the bridge is 350.28 meters. So that's how far down it goes. And that's why it's represented as a negative, because it's going down. Okay. Let's look at my next one. Throwing stones. Jin throws a stone into the air. The height of the stone above the ground can be modeled by the equation f of t equals 1 plus 7.25t minus 1.875t squared, where t is time in seconds that has passed since the stone was thrown, and f of t is the height of the stone in meters. We have to find the maximum of the height, and we have to determine how long it takes for the stone to land on the ground. Now here's the thing, this isn't in proper standard form. We have that t squared is last. So don't get fooled by how it's written. We can simply rearrange this if it makes you feel better if you had to do this by hand. This is a minus, so it's going to be negative 1.875 t squared. This is a plus, so plus 7.25t, and then this 1 is positive, so plus 1. So we can just rearrange it, taking the sign in front of that coefficient, in front of that number, negative 1, positive 7, positive 1, just changing them around, and now we have that proper standard form. Now, we're not going to have to rearrange this. We're not doing this by hand. We're doing this with a graph because the point of today's lesson is actually locating where that maximum height is and determining how long it takes for the stone to land on the ground. So we're going to go to Desmos, and we're going to put this in. We're going to graph it, and then we're going to label everything. So let's go to Desmos, let's graph it, and let's label. T is time in seconds, so that's T. F of T is going to be our Y value, and that is going to be the height of the stone in meters. Voila. Here we go. Graph of throwing stones. I graphed this in Desmos. I labeled each part. So time since the stone was thrown and the height of the stone in meters. So this is that T, this is T, and this is F of T. and I labeled each one. Time is the first one, height is the second one. Time is the first one, height is the second one. Now, I didn't label this because this one is negative, and the negative time, this point right here is really not included. What's happening is we have this person, we have Jin, and I'm going to draw a little guy, and here's the stone. So Jin is holding the stone. So this point right here, this is actually 0, no time has passed, and 1, the height of the stone. So he's holding it in his hand right now. Then what he's going to do is he's going to throw it up, and it's going to hit this maximum point, and then the stone's going to come back all the way down to the ground. So that's him right there. So this point below, that's really not part of what we're looking for. Okay, so I need you to imagine, this Jin throwing that stone up and it hitting the ground. So let's go back and see what our questions wanted. Part A, find the maximum height that the stone reaches. So remember, maximum height is going to be the vertex right here. Now, since I have everything labeled, I'm going to look. Where was that maximum height? Oh, look, height of stone in meters. So that's the maximum height. So part A, maximum height of stone is 8.008 meters. Perfect. We found it. All right, part B. Part B says determine how long it takes for the stone to land on the ground. How long it takes. Grammatical error. So how long does it take for the stone? So here his time is 0. He throws it up. It reaches its max height. It comes back down here. So we're looking for this point. So this point is 4, 0. So 0 is the height, meaning it must have hit the ground. So that's where it hit the ground. Oops, not the ground, the ground. Okay. So how long did it take for it to hit the ground? Time since stone was thrown in seconds. Oh, 4 seconds. So it took 4 seconds to hit the ground. And so I'm really hoping that doing this through with you and not really worrying about, how we're getting the numbers is just through Desmos, but really labeling what the numbers are and understanding the problem. Hopefully this is helping a lot of you. Okay, let's go to the next one. We have this one and one more. So we have a skate park. A ramp in a skateboard park is modeled by a curve with the equation f of x equals 10.67 minus 1.67x plus 0.0417x squared, where x is the horizontal distance in meters and f of x is the height above the ground in meters. Find the maximum depth of the run and find the x-intercepts and explain what these values represent. So first, let's look at our equation. It's not in standard form. So if we were going to do this by hand, it may be good to rewrite it. I'm just going to rewrite it because some people might want me to rewrite it. So this is 0.0417x squared. This is a minus 1.67x, and this is positive 10.67. So if you want to see it in proper standard form, there you go. We don't really need it. We can just put it like this in Desmos. And remember, let's graph it in Desmos, and then let's label all of our x's as the horizontal distance in meters, so all of those first numbers, and then all of those second numbers, f of x, as the height above the ground in meters. So I'm thinking it's going to look a little bit different than this. I actually think it goes down like a pool. I think it's going to go below the ground because it says height above ground in meters. So let's see what this looks like in Desmos and then answer the questions. All right, here's my skate park. Okay, so I went through, again, all of my x values I labeled. This is a comma here. So this number, horizontal distance in meters. This number, height above the ground. This number, horizontal distance in meters. This one, height above the ground. Horizontal distance in meters, height above the ground. Again, I didn't label the y-intercept. And this is I didn't label it because here's the thing, height above ground in meters. I really think the skate park that they're talking about, the actual ramp of the skate park, is this ramp right here. So I think, yes, my very bad stick figures, I think there's a little guy, a person here on a skateboard, and he's going to go down and then back up. So this part of the graph we're not concerned about, and actually this part of the graph. So the only part of the graph that we're concerned about is where it starts on the ground and then where it goes under and then where it goes back up. So if you think about it like a pool almost, that's pretty cool. If you took a pool and turned into a little skate ramp, that would be awesome. Maybe a little scary. So that's what he's doing, and then he's going and he's getting back up here. So these are the only points that we really need to be concerned about. All right, so part A, find the maximum depth of the run. All right, so depth is going to be the height below, and so maximum depth, you're absolutely right. We're looking for the height above the ground. So when they talk about height above the ground, they're talking about depth. So this is actually negative. So this is actually below ground. Okay, so in our, where am I going to write my answers here? Part A. So we can say skateboard park, the skateboard curve, ramp, run. Ramp is the run, that's what they're talking about if you didn't know what a run is 6.05 meters below the ground. And I'm just using the word below to represent this negative right here. Because this is right here, that is the vertex. This number is the vertex. And if we're looking for depth, we're looking for that height. And since it's negative, that means it's below the ground. All right, let's go on to part B. Find the x-intercepts and explain what these values represent. Okay, so here are my two x-intercepts. Here's the first one, and here's the second one. So I'm just going to put a little box around this number and a little, oh, not that one. Here's, not that one. This one. And a little box around this one because there's a lot going on. So here's my first x-intercept, here's my second, here's my first, here's my second. And if this picture is confusing you, what you could do is you could go to Desmos and you can put this in. And then when you click on the point right here, your number is going to come up. And if you click on this point right here, the other x-intercept, this number is going to come up. So if you're like, there's a lot on this paper, do it, go and do it for yourself and click on those points and see what you get. So here are my x-intercepts. So I would write down these 2 points. But here's the thing, what do they represent? We're actually going to have to subtract them because remember, they're horizontal distances. This is like my bridge problem, everybody. This is like my bridge problem where our ramp is going from here all the way over to here. So we're going to have to, part B, you would write these points down and then you would subtract and I didn't automatically subtract this, so let me just get out my calculator because I forgot.